Well, hi, and welcome to my shop here on November 25th. A gray, rainy day here. And the snow, which looked like about that a couple days ago, looks like that now. It's all washed away, which is typical for November weather here. Snow, then rain, then snow, then rain. And ugly the whole time. So that's November. I've worked away on a couple of tube stages here, output tube and the RF tube, and up here, and then I got to the detector tube. And what did I detect there? I detected a problem with the power supply, a couple of resistors, which I've replaced here with this big guy here. But I never really finished checking through here. This is the detector tube, as I mentioned. I didn't really check this thoroughly yet. So we're going to get back to doing that. I did check the one measurement, which was corrected after I installed this. It was surprising death of, well, maybe not so surprising. Maybe not so surprising. Death of a couple of big carbon resistors there. Okay. Do I know what I'm doing here? Sometimes I come in my shop to start these things in the morning, and I literally just turn everything on, including the cameras, and away I go. But I did take a look at this briefly on my own, so I just wanted to get an idea where I'm going after I finish this tube. And you can look at this radio and the signal flow through it this way. You can say it. Maybe we'll start here. This is the RF tube, so it's coming from the antenna to this tube, out of this tube, over to the detector tube. Not the detector tube, that's the problem. Mixer tube, mixer tube, mixer tube. This is the mixer tube. Oh boy. What a mess. What a mess. Well, hi, good morning. Thanks so much for joining me here in my shop on November 25th. A cold, gray, rainy day here. Very ugly. November weather typically around here is kind of sad, and such is the case. So, I've taken a look at the output tube. I've taken a look at the first RF tube, which is up here. I then made it over to the mixer tube over here, and discovered at that point, through resistance measurements, that there was something wrong in the power supply way down here with a couple of resistors, which I've changed out and replaced with this guy. Check the set. The set is working, so time to continue on with looking at this tube. But first, my eye caught something right here, which we're going to take a closer look at right now and see what it really is, because it is something kind of small. So we're looking right above my finger here, and you see what looks like a knot tied around the wire there. You know what's going on? The wire, the green wire, the set has not been on yet today, so I'm sticking my finger in. It's coming down, and then there's this weird knot. But it's not a knot. It's a coil. This is a gimmick. This is a technique for creating a small capacitor where you wrap an insulated wire around perhaps another insulated wire. There's no wire contact. The other wire's leaving here. And this might represent a picofarad or 2 or 3. This is a small coil, but it's wrapped pretty tightly in there. So those kinds of things, when you first encounter them, if you've never seen it before, you might think, what kind of a dumb thing is this, and remove it. You could replace that with a tiny capacitor. Sooner or later we'll get to this when we get down to this tube. But it's worth noting its existence right now. And of course, this just gives you an idea of how disturbing these wires. Yeah, I mean, if that little wrap has some kind of effect on this radio, then the position of everything is having an effect. Well, not everything, but obviously, not so obviously. Could be the case that the position of some of these components is absolutely critical to the operation of the radio, and we're not going to know which one until it's too late. That's another good reason for not shotgunning capacitors, which means to just get in there and change them all, and then turn the set on, with your fingers crossed. That's probably a very risky thing to do, especially with this many capacitors. Okay, so we want to carry on with the resistance measurements on the mixer tube, and see where we go here. So on my own computer over here, out of your sight, I'm going to put up the chart so I can read it, because the print is unbelievably small. Wow, you want to see unbelievably small print. Have a look at this. A new addition to my shop, I have a 2 meter ham radio monitoring the local repeater here. The print on this screen is so tiny, and I'm not even going to show it properly in the camera, that you need a magnifying glass to see the little indications, and not the big number you can read, but the little tiny indications that come up while you're pushing the myriad of buttons to activate the ridiculous number of features in these radios. And that's not even a particularly new one. So if you might hear it come to life while I'm working away here. Okay, we're ready to go. So we're going to do the mixer tube 6SA7. So we start with pin 3, which is supposed to be 32,000 ohms. Pin 3. So pin 3 is the one I worked on. Here it is. Okay, so it's going up 36 or so. But that's close enough. Okay, the next one. The next one should read 42. It's going up a little high also. 45, 42, I'm not going to worry about that. Next one. Next one should be 18. Bingo, 18. Next one should be 11. 11 ohms. 11 ohms. Can I even read that? I think I encountered this before and wondered what was I going to do about it. So instead of 11, it's 25. Is anybody making any differences here? I don't think so. I'll have to look at this one a little closer. What it was. An 11 ohm reading is kind of weird. Next one should be 0.1. Okay, so it's going to show up 0.5 on the meter there. It's probably, 0.1, 0.5, that's a factor of 5. I'm not going to worry about it. 33 ohms on pin number 8. 40 ohms. So all reading just a little bit high. Now let's go back to this one here. 24 ohms. What is it? I remember looking at this already. It was going through a coil. And I don't think we're going to be able to sort it out unless this is it right here. Look at this. Brown, black, black. So the wire goes from the pin I'm testing up to here. We get the same thing again, 24. Around and under and up to here. 22. 23. 3. And then there's this resistor here, adding a little. I don't know what I'm doing. So we're going to find this resistor. Brown, black, black. 100, 100 ohm resistor here. Can that be part of this picture? How does a 100 ohm resistor interfere with yeah, we gotta look in the schematic for this to find out what it is. I mean, it's reading lower than it should be. Uh-oh. Gosh, you need to say it's almost 11 o'clock this morning already. Yeah, 11 o'clock, the local ham club has a coffee club meeting every morning. and they're about to do it, so I just turned the volume down so we don't listen to the old guys chatting there. Yeah, let's go on to schematic and find out what is happening with this coming off of pin number 6, I think it was. Pin number 6. Let's take a look here. Pin number 6 is right here. Wow, it's a cathode. Be a cathode resistor. There it is, 10 ohms. 10 ohms. And it's tied into these coils. Apparently I didn't turn the volume down on my little radio there. 10 ohms. And what did I read it? I read it. Now, can I possibly read this? Oh boy, oh boy. Band selector would affect the reading here, I think. Let's take a reading on that resistor again. I mean, it's easy to replace a 10 ohm resistor, but why do it if it's, you know, I like the guesswork. Okay, let's read it again. I'm going to hook up the ohm meter to it, across it. If you're fairly new to my videos, I like to do things in a way that is going to teach me something, teach me a hard lesson. And so sometimes I dwell on things that people would normally say, just replace the stupid thing, keep going. I'd rather poke around a bit. So instead of 10 ohms, we're getting 27 ohms. Now wait a minute, that was totally different than the last reading, wasn't it? Let's go right on the actual read here. 23. Why are we getting different readings? Is this another capacitor that if you touch it, it goes ringy? I wouldn't call that ringy. It's probably just clip leads. Wait, reading these low resistances, you know, clip leads involved, everything's involved. Just double check everything here. $27 ohms. Let me just turn this down here. Yeah. Okay. Easy way would be to nip the resistor on one end and measure it again. That would be the easy thing to do. But why do it that way? What I thought was band changes might affect this reading. Now we're reading 4 ohms. So if you connect across a 10 ohm resistor, you should see 10 ohms or less. If you see more, it indicates the resistor is having gone high. From 10, let's say, to 26, I bet you it's even higher than that. Okay, so we're going to nip one end of this guy because it's almost, you know, according to this measurement, it's almost three times its proper rating. Let's see what happens here. $23 ohms. Okay, so how much of that is quick lead? Let's find out. little bit of it. It's still reading double what it should be. Okay, so I'm going to stick a 10 ohm resistor in there. Okay, is there a chance there's something going on with my meter and whatnot? So I have a 10 ohm resistor out here. Claims to be a 10 ohm resistor. Look at that, 9 point. Yeah, okay. That certainly seals the deal. So I'm going to go ahead and change out this resistor. I'll put this guy in. Carry on. Uh-oh, something happened there. Something happened. I was trying to wrap the new lead around. What happened here? Let me get my poker. Here. This terminal just suddenly started hopping around. Oh, it's come off. Oh boy. Well, there's a lesson. That means all these things are fragile. See, there's a better view of some here. These guys are all fragile. Wow, I mean, did it really break right off? Somewhere way down? It still feels springy. Oh, look at that. Come on, camera. I got autofocus doing this? Yes. Drag on the autofocus so you can see it. Oh, it just broke the, wow. Okay, it's still connected down below, and if I get this resistor in, it'll solidify it all, but I better not be wrenching on it, twisting in particular. You know, that's kind of par for the course when you're working on these old guys. You're very well meaning as you do something, and the result could be deadly. Now, where's the other end of that lead go? Can I remember? Where are we up in here? So I think I'm going to want to stabilize the resistor. Bring this lead up. There. Another pair of pliers. What is this? A fruit fly? Where did a fruit fly come from? How can there be a fruit fly flying around? That's a little odd. That's really odd. Yeah, like anybody, and whoosh, right in front of my face there. But like anybody, we get fruit flies in the house in the summer. Where the heck would a fruit fly come from at this time? Carefully now. Okay. So I'm thinking this terminal that has come free up here is connected to a very light wire inside the coil. And monkey business with it, and there's going to be trouble inside this coil, and that just be disaster at the top of the list. Top of the list of disasters. Do not want that to happen. Don't know what band this is, but my objective here is to make this radio work really, really well. And put it into, well, I wouldn't say regular use, but available for use. Every so often I get the urge to fire up all my old radios, better ones, and listen. And I'd like this to be one of them. Okay, we've solidified that end. Now we got a solder up in there. See, this wire's in the way here, but I don't dare swing it down to get it out of the way for fear I'm going to cause something that I would never be able to figure out later what had happened. And probably overdoing it on the concern there, but better safe than sorry. Okay, I think I got that in soldered in. That should stabilize the terminal. You know, another thing is too, if the terminal comes loose, then vibrating the radio will cause the terminal to vibrate and cause an effect in the radio of some sort. Okay, that's as good as it's going to get. So, oh, come on. Okay, that was a close call for sure. But now I know that all these have to be treated as if they're fragile, very fragile. But you don't expect to be doing too much in here. Could show there's just a little wire tail there. Yeah, this is where everything goes south, right here. Trying to cut this off. A lot of forces involved when you use cutters. And I lost a piece of wire. So I'm going to blow it out of there. I think I heard it hit the deck down here. I don't see it though. Well, that was foolish too. Okay. So now if I take that reading, which I really should, we should see a much more expected result. It's here. There we are, 9.5 ohms instead of 10. Thumbs up on that. So that finished off. Ooh, did I just see the lights flashing here? Oh, again. So what I've noticed about LED lights, some LED lights are extremely sensitive to any variation in house voltage, like starting up your vacuum cleaner or something like that, much more than incandescent lights, because I guess they had a certain amount of thermal momentum, if you like. Wow, what's flickering here? So I have a couple of clocks. You probably have the same situation. A couple of clocks that are really sensitive also, so they tend to go off. A little flicker. I'm looking around. Okay. Okay, maybe some squirrel bit the dust on a transformer out back or something like that. So we're done here. Oh, capacitors. We have capacitors here. So this one's in the area, but it's really connected over this way, grounded here. This is the one with the sliding cover. I think while we're in the neighborhood, we should change this. This guy, there's a terminal strip tucked away in here. He should go too. Yeah, it is involved with this tube. So why don't we take a look for this one on the schematic, see what it is. There's a mica one up in behind there, which I would tend to leave myself, unless there's some clear reason for going at it. Very odd how this has been soldered in and wound around there. 0.01 coming from 0.01 associated with the mixer tube. 0.01 associated with the mixer tube. That might be in the mica one there. No. Oh, way down to here? No. Oh, it's not showing up here. Well, what's going on? Let's see if I can trace it. Just bear with me while I'm looking back at the radio here. And I would say one end is connected to pin number 4. Pin number 4 is what I would say you're looking for. So you follow 4. Oh, it's right on pin 4. Like it's not on the other side of this. This just gives me the willy-nillys. What am I doing wrong here? You know what I'm doing wrong? I need to admit to this. I think I got 2 tubes mixed up. That's the thing about doing these things live. And you make a stupid boo-boo, I think this is the RF tube. No, it isn't. No. This is definitely the RF tube. This is definitely the mixer tube. How definite can you get? 6SA7. Okay, something's not adding up. 6SA7. I can clearly see the connection to this capacitor. There's no question it is. The question is it on pin number 1, 2, 3, 4? It's on pin 4. 0.01 on pin 4. 6SA7, 4. Come down, there should be a 10K resistor coming off. Okay, so look back at the radio, and there's a big 10K in there, big whopper. That's there. And you know what? This is quite different. Oh my gosh, don't tell me I still don't have the right schematic. Which one am I looking at here? Number 80. I'm looking at the wrong schematic. Well, it's interesting finding these little differences, but you can imagine when they're forced into making this change in the power supply and move up to a more modern tube partway through manufacturing this radio. And in the course of doing that, the engineers probably said, here's 3 more changes we want to make that we've discovered we should make. And it could be right in here. Wait a minute now, you can't have a capacitor. You can have a capacitor going to ground, but you can't have a capacitor like in this line here. Okay, must be another wire off the same pin. Oh. Okay. Let's just switch back here. I'm misinterpreting this. So we come off the pin of the tube and we go over to a terminal strip where 2 things are connected. This capacitor going back to this coil, and this big resistor here, brown, black, orange, this great big guy is 10K. This big guy here, oh my gosh, there's a resistor hidden up in there. You got parts hidden away here. Just quickly looking for more hidden parts. No. So this guy's coming from, is basically connected straight to pin 4 and then going up to this coil. So it's off the pin ahead of the resistor, but that's not what the schematic shows. So there's the 10K. There's no capacitor shown here, but there's in the radio there's a capacitor from here. And where is it going? It's going to one of the coils. Oh my gosh. And a wafer switch. It's basically going to a wafer switch and some other parts. The switch is showing way down here. And you can't, well, you can get there. You can't get there except to go through this. I don't get it. It's not adding up. This goes way over here. It just disappears into all this stuff. Well, time to stop for a bit. When things aren't adding up like this, I get a little nervous that there's something here I'm just not getting. And I mean, I can replace the part, part for part. That can easily be done. That's probably what I'm going to do. But, let's read that big 10K resistor there and see how big a job is ahead of me. Okay, Mr. Big 10K. Right across it. 10. I could be fooled. this could be the resistor's gone high and there's other circuit elements that are dragging down the reading. It's just lucky it comes back to 10, making me all happy when I shouldn't be. I think what I'm going to do is I'm going to stop for a bit, and then when I come back we'll carry on with what's going on with this guy. I can really identify what this terminal is. I have to figure out what each of these pieces are. Shouldn't be too hard. A mystery. More mysteries. So many mysteries. Okay, here's the more correct schematic. It's got the correct rectifier tube here. Fortunately, it's not quite as nice looking as the other one, but we look at what we're interested in. 6SA7, pin number 4. Come down, there's the 10,000. Where is the capacitor? And I don't get it. This might be it. Now the way this is hard to look at, but the way they show capacitors is if it's large enough to be a microfarad capacitor, then they put MFD after it, microfarad. If they don't, then it's a picofarad capacitor, like this, 220 picofarads here. This looks like it's a picofarad capacitor. I mean, it's possible we're seeing a later revision to the radio. You know, my radio has the built-in meter, so assuming that meter wasn't a kit put in by somebody, which I kind of think it was, if this was done in the factory, then they might have taken the opportunity to make updates. And that might explain the curious way that capacitor is installed. It's just, the wires just run a little bit in a funny way. Well, anyway, my only option is remove it. Ooh, that doesn't sound like a good idea. Sounds like a good idea to have a capacitor here. I got to figure out where that capacitor is going. I don't think it's going to ground. I think it's doing something else. Okay, so it's this guy we're talking about. The curious wiring is a little hard to see in the camera, but it's not so much this thing's wiring, it's this bare wire that's running up behind there. It's kind of threaded around through things. It's just a little odd. It's just not what you expect to see coming from a factory situation. Is this added on later? It doesn't look like it. I don't know what to make of it. So we need to identify, we know where this end of the capacitor is. We need to find out this end. How can we figure out where that is? Let's see, it's going to the band switch. So it's basically from here through a capacitor on this leg of the coil, assuming this is an active, well, maybe it's a transformer because there's 2 here and 2 here, or 2 here, 2 here. Maybe this is a transformer here. And I don't even know which band this is. Maybe I can figure that out too. I don't know if that would help. Might help. Looking at the schematic. Goes straight from here to a switch. So capacitor goes to the coil and switch. And there's this guy sitting here too. Okay, I'm going to study that schematic until I sort this out. Okay, well, I could not sort things out. Which makes me aware now that maybe the schematic, even the one that shows the 5Y3, may not match this radio perfectly. So I've just gone ahead and replaced it with a 0.01 and used this style of capacitor there. Might as well deal with this one since we're right in the neighborhood. It's on the far side of the resistor. And it's a wire that goes down to the power supply. It would look like this is a screen supply here. This is going to ground down at this end. So this is almost certainly a screen decoupling capacitor intended to quell any RF that might be in the line at this point. So 0.05. Let's look at it on the schematic just to be sure of things. Oh no, don't do that. Okay, 6SA7 coming down off pin 4. There's the big 10K 1 watt resistor, and look, there is the capacitor, 0.05, going to ground. And that's a decoupling capacitor for sure. Okay, we'll replace that. Well, somewhere along the line I seem to have lost one of the 2 capacitors I just took out. Got the bigger one here. But that's a really weird thing. That 0.01 appears to be just lost in my shop. I don't like that. Okay. Maybe I ran through the house with it. I don't know. Let's try this guy. Now this is the one that looks like the outer cardboard shell has slid down on it. Or the guts are pushing their way out. It's all kind of odd. This is potentially a hard working capacitor. It's got the screen voltage across it. So here we go. 50 volts. Watching the eye. It came open a little bit. And I'm sure if we get it 150, it's never going to open on that. No surprises here. Every capacitor is testing consistently bad enough to warrant replacement. So I think, look how many we've done here, plus one that's escaped. It's pretty clear that all these capacitors are going to go. Okay, so there's a new one in, a new one in. And I think this kind of clears out this area. And we'll be on to the next thing. Let's just take a look at the signal path in the radio here. Coming out of the mixer tube. I'm sorry if I'm still calling this the detector tube by accident. Actually, I could call it the first detector, because it's often called the first detector in older documentation and the like. But let's call it the mixer tube. Sometimes it's called the frequency shifter. All kinds of names for this thing. Signal comes out of here, goes into the transformer. The transformers are these square openings here. Goes into the transformer, out into the RF amp. Don't stick your finger in there, Jim. Into the RF amplifier, into another IF, out through another amplifier, into another IF, and then into the second detector or detector. So following it along then, this guy is next, and he's just crowded with capacitors. Got this great big whopper hooked up here. Okay, so we're going to start with the resistance measurements on it. And it's very late in the afternoon here, so maybe after I do these measurements I'm going to stop in favor of doing other fun things. Okay, and what are the measurements? Just looking on the paper chart here, this will be the first. Six SK7. Let me be absolutely sure here, because although I never make mistakes, 6 SK7. There could always be a first time, so I got a 6 SK7. This is 6 SK7 number 1. We are looking at we are looking at something so small I can't read it. Okay, but if I hold these leads in my hand, I'm going to poke my eye out. Okay, here we go. We should find on pin 3, 330 ohms on pin 3. 330 ohms on pin 3. Of this tube. 1, 2, 3. Oh, wait a minute. 1 and 2 fused together. 1, 2, this is 3. What do we got there? Looks like 1300 ohms. That's what it looked like. 1300 ohms. What did I say it should be? 3. 330 ohms. Ooh, this one's way out. Looks like this is the guy here. This would be brown, black, red. So 1, 0. This is 1,000. This is 1,000 ohm resistor there. So on this side of it, we get wild readings. It's probably just from bad contact. Well, that would look like 14 ohms. That's on the other side. Is there Cathode in here? Going back to where we want to do this. 1, 2, 3. 3, same here. 1300. All there is. Okay, so there's comes around to this capacitor here. And this guy looks like he's hooked up between these pins. This pin appears to be grounded over here. Yeah, we get a 0 on the meter. So it could be this guy's leaky. That would make the resistance look even lower. 1300. Geez, creepers, this is really quite a journey here. How do you get 1300 on there? And then we have this capacitor. Just going from this terminal. This is not a ground terminal. But it's going to ground over here. In fact, this one, and this one are all grounded here. Well, that's kind of interesting. As I say, I'm on my way to replacing all these. Let's nip one that we think might be interfering with this reading, although I can't see how. I'm going to nip it right here. Okay, just make sure it's separate. Did that do anything? 13, no. How do we get that? Okay, I'm going to stop and study the schematic and figure out how we can get a reading the way we're getting it. How can it be 330 ohms? It can be 330 because I've read the wrong line. Again, 330 ohms. The other 6SK on the same pin is 470. That's probably the cathode. Those are probably cathode resistors. And I probably nipped the cathode bypass capacitor right there. Cathode resistors, eh? Okay, so we think we're on this tube here. And we'd be looking at pin number 3, 470. 470. 470 into this wire. Another cathode. Or 70. Wait a minute. There has to be some kind of something more than a standby socket. What's happening here? 470, 1080 over here. The other 6SK. So, no. So there's the capacitor. Looks like 0.05. That makes sense. 470, 1080. But in this radio, this 470 appears to be 1000, especially if it goes and connects to another resistor here. Well, there's the ground right there through this resistor. And it looks like a big one, 330K. I'm not getting it. I'm not getting it. 470, I would expect the ground to be on this line. only access to ground is through here. You really have to kind of twist your mind around to picture what's really going on. And the way they lay these parts out in a schematic is more for controlling white space on the drafting drawing. Oh boy. Okay, let's see if we can find this guy then. A big resistor hooked up to this thing which looks like 1,000. Big resistor. Okay, so where are we again? Totally lost here. We're here. And we're thinking this resistor is the one in question. It's a 1,000. Brown, black, red. Over here is a 33. Well, I have to guess 30. I don't know. Look at that. So it's got two nice orange bands, and then the last one, wow, it looks brown. Camera's not doing so good on it. And it's going to pin over here. I don't know what to make of that. This is just not matching well at all. So the fact that I get a reading of 1300, maybe that's the correct reading, because now if this is a brown, then it's 330. 330. 330. That's what this says. 330. The chart says 330. By observation, how can that possibly be? There's a wire here. That's going way up in there. There's another wire. No, there isn't. There's just this wire going up to parts unknown. Literally, it's going up. Looks like it's attaching to this resistor that I changed out. You can measure across this, see what we get. If you're hearing some thumping in the background, if your speakers are big enough, or you're wearing headphones, you can hear some thumping. That's the dryer tumbling clothes next door to me. Okay. It's not my heart pounding. That's not what your regular heartbeat. 6,000 scale. What do you say, man? Ooh. Not going to be overloaded. I can get a good grip on it here. I think we all know what that is. 1369, the very same reading. That guy is gone from 1,000 up to 1369. That's and you could argue, wow, okay, if it's gone to 1369 and they said it's cold right now, warm the setup, maybe it's going to go higher, and where's it going in life? It's only going higher in life anyway. So put a proper 1,000 in here, assuming this is correct. I don't know what else to do. And we'll get rid of that one. While I'm here, why don't we take a look at this 330 one? 875. Oh my gosh, these are all shot. When I first started on this radio, turned it on and it seemed to work really well. I thought, wow, I'll hardly have to do anything to it. False notion. So I changed these two. Ended up changing every part in here eventually. Okay, I'm going to call it quits here for today. Come in tomorrow. Before I turn the cameras on, I'll change those two resistors, or I'll come in here later tonight when I'm bored and change them then, so we're ready to go tomorrow on that. And the 3 capacitors here I'm bound to do also. I'm going to have to my stock. It's going to eat my stock. Thanks a lot for watching, and hope you're enjoying this. It's a very tedious process, so I appreciate the fact that you're hanging on. You're just on the edge of your seats watching this thing. See ya.